Howdy. I just stumbled across this one. Obviously, it's 2 hours old or something. I haven't read it, but since I was going to, I thought I'd make a video so we make read through. I don't know. It sounds interesting. Severe weather in Europe, or the severe weather Europe. An unusual ocean anomaly is growing in the North Pacific. How did it form and what does it indicate for the weather seasons ahead? A strong oceanic heat wave has formed in the North Pacific following the weather pattern changes. These unusual anomalies can impact the region weather and marine ecosystem, but also have a wider meaning for the upcoming weather seasons. A heat wave in the oceans is very similar to an atmospheric heat wave, which we all know is hot or very hot weather. The ocean temperatures can also rise above the normal levels due to changes in atmospheric pressure and wind patterns. We will look at the latest such event developing in the North Pacific, how it forms and what it can tell us about the weather in the upcoming weather seasons. I think it's this one they're talking about. I don't know. Oceanic heat waves. The heat waves in the oceans are better known as marine heat waves, or MHWs. These marine heat waves are defined when temperatures are much warmer than normal for an expected period of time. They can have significant impacts on marine ecosystems and the food industry. The map below shows the typical global areas where these ocean heat waves occur. We will focus on the North Pacific today, as it is developing a new strong oceanic heat wave. Yeah, the blob. As you can see in the North Pacific, warm blob, yeah, it is the blob, of 2013 and 15 was the longest such event so far. It also caused unseasonably warm weather in the Pacific Northwest of the United States and Canada. The image below shows the average progress of a marine heat wave event. Usually in early phase it starts with warmer than normal anomaly spike days. It takes consecutive days with abnormal temperatures to define an anomaly as an oceanic heat wave event. Climatological mean. Threshold. So we are far over the threshold. Below is current global ocean temperature anomaly map showing where the ocean temperatures are warmer, colder than normal. We can see a strong warm anomaly in the North Pacific Ocean. It features temperature anomalies over 5 degrees Celsius. Yeah, I made my own videos about temperature anomalies in the Baltic Sea, North Sea, many other places as well. Looking closer at the Pacific Basin, we can see the nice temperature contrast between the tropics and the North Pacific. There is an actual connection. As usually, the tropical anomalies are reversed in the North Pacific. Here we see the active La Nina in the tropical Pacific. This is called an atmospheric bridge. You can see that in the image below, revealing the connection between the tropics and the North Pacific. It is opposite to what we have now, but the principles is the same. Pressure and wind patterns change, affecting the circulation. Atmospheric bridge. Yes, they are connected with each other. And not only in the atmosphere, but also in the ground. The video below shows the temperature anomaly development in the North Pacific since May. You can see the onset of The strong oceanic heat wave in the North Pacific starting in May, but the strong warm blob developed in July. Click to play. Yes. As mentioned, the development of this oceanic event began in May, right after the spring equinox, maybe. In the mid-month, a high-pressure area was strengthening over the Aleutians. The strong low-pressure area was present over the northwestern United States and Canada. Yeah. Looking at the ocean temperature anomalies in the region, we can see ocean surface cooling in the northeastern Pacific from the low-pressure anomaly over the United States and Canada. Persistent warm anomalies are seen in the central North Pacific. Persistent anomalies. They are like oxymoroning all the way through that. The high-pressure system moved farther east in the next month. This temporarily reversed the developing cold anomalies in the far northeastern Pacific, making the weather there calmer and lowering the heat exchange from the ocean to the air. We can see the mid-June ocean anomaly image below, that the cold coastal anomalies have turned into warm anomalies. In the far northeast Pacific. That shows the effect high-pressure system can have on ocean surface anomalies. Yes. A warm blob appears, but there was a pattern change in the North Pacific going into July. A strong low-pressure system came down from the north and over the Aleutians. As a result, a strong high-pressure system has strengthened over the central North Pacific. That plays a key role in this whole story. The main effect of this high-pressure system is that it lowers the rate of heat loss from the sea to the atmosphere. That is due to the warmer air above the surface and the very calm weather. Weak winds mean calmer ocean surface and less mixing of the ocean waters. The ocean gets colder the deeper you go. So low-pressure systems and strong winds create waves and rough seas, mixing the warm top layers with deeper, colder layers, thus cooling the ocean surface. There is much less mixing and cooling with calm weather, and sea surface temperatures can rise. The image below shows the anomalous southerly and westerly winds around the high-pressure system in the far North Pacific Ocean. Westerly and southerly winds promote warming from the ocean surface, while easterly winds promote ocean mixing and upwelling, cooling. Okay. We have special graphic below from the NOAA Coral Reef Watch Project. It shows 7 days temperature trend on the ocean surface. We can see strong warming trend developing from the west in the central North Pacific, related to the push of westerly winds. Okay. Combined with the effects of a high-pressure system that has helped to kickstart the large warm ocean anomaly in the far North Pacific Ocean surface, Temperature rose 3 to 4 degrees Celsius over a wider area. This is the beginning of the so-called warm blob anomaly. Now it has a name, the warm blob. The anomaly grows. Going into mid-July, the strong low-pressure area moved from the Aleutians into western Canada. The high-pressure system remained stationary in the North Pacific. A smaller low-pressure area moved in from the west, interacting with the high pressure in the North Pacific. Okay. The interaction between the pressure systems is best in the wind analysis. We can see a strong push of westerly and southerly winds around the high-pressure system. It is amplified by the pressure difference between the weather systems. That's channeling it. Pinching. We can see the combined effect of the high-pressure system and wind patterns on the sea surface temperature trends below. In mid-July, the 7-day trend showed an area of strong temperature increase. Boy, they have many pictures here. We can see a large area of an abnormally warm waters looking at the actual anomalies. That's the final birth of the currently ongoing warm blob event, or an oceanic heat wave. It is a combined result of pressure and wind patterns. The NOAA Coral Reef Watch Project also produces special graphics revealing oceanic hotspots worldwide. As you can see in the image below, the strong warm anomaly in the North Pacific has lit up the area very quickly. Yes, we can. In late July, the low-pressure system in the North Pacific moved further east. The high-pressure area has begun to weaken. A broad southerly and westerly wind field has developed between the pressure systems. This one, I guess. Yes. Looking at the wind analysis, we can see anomalous southerly winds developing in between the two pressure systems. This provided means of sustaining the warm anomaly in the North Pacific Ocean. Below we can see the oceanic heatwave anomaly in the North Pacific, and last day of July compared to a week before it has extended further to the east. Yes, the latest ocean analysis. But what is the current status of this warm blob anomaly? Looking first at the actual ocean surface temperatures, we can see the ridging of the ocean surface. This shows that the ocean waters are not necessarily hot or warm, as the anomaly suggests, but higher than normal temperatures reach much further to the north than ordinary. The coral bleaching alert system has also detected this North Pacific heat wave at the warning level for coral bleaching. But this is not a concern, as the water there is deep with no corals at the surface level. But if there were, the temperatures would be hazardous for the corals and their ecosystems over a wide area. No stress watch warning alert level 1 and 2 and no data. Temperature trends from the NOAA analysis show continued warming of the ocean surface in the North Pacific. The main area of temperature increase is around the hotspot. Really? Spreading towards the north and the east. The main area of temperature increase is around the hotspot. The main area of the temperature increase is around the hotspot. Really? Hopefully this is over soon, this article. Temperature anomaly shows this spread towards the east as the 4 to 5 degree anomalies are now approaching the 150 degrees westerly longitude. Anomalies have also increased to the north aided by southerly winds. Below is another special product from NOAA Coral Watch showing the heating weeks. The graphic shows accumulated heat stress during the most recent 12-week period. We can see quite strong values over 12 degrees, indicating a strong hotspot developing. Yes, but there is one more way to look at this developing oceanic heat wave. By looking at depth across the anomaly, we can see its extend downwards. The analysis below shows that the strongest anomalies reach no further than 20 to 40 meters. What? By looking at depth across the anomaly, we can see its extend downwards. The analysis below shows that the strongest anomalies reach no further than 20 to 40 meters. Yeah, the strongest maybe, but if this color spectrum is also already above normal, how do they explain the spikes which come from below? They don't talk about these at all. At all. Check it out. They don't talk about these. Maybe. Let's see. Let's read to the end. This confirms that the weather event is linked to changes in weather patterns over the North Pacific Ocean and North America ocean surface. Changes from weather patterns are normally limited to the uppermost layers of the ocean, but they are coming from below. If this means somewhat 3.5 degrees, what's wrong with that? This extending, this also, they're all going down and they are coming up. They don't talk about these. Yeah, this is very long, obviously. We can see this in the wind forecast from the ECMW assembled system. The high and low. Yeah, I don't want to read that whole. That's endless. Yeah. The ocean temperature anomaly forecast shows the continued presence of this hotspot in the North Pacific. It is forecast to extend further to the east. Strong warm anomalies over 4 degrees Celsius are sustained over a wide area. Bad weather. The weekly temperature change forecast shows the spreading of this hotspot to the east, but we can also see another area of temperature increase further over the west, also relating to changing weather patterns in the region. But this is not the first such ocean heatwave in the North Pacific. There were a few strong events in recent years. Below we have the ocean anomaly analysis for last July showing a similar but weaker event. This anomaly was closer to the west coast of the United States. There is Earth's mantle shifting. Probably. At least to some extent it's going on. There's many things going on underneath our feet. We had La Palma, we had Iceland, then we had Tonga, now we have Iceland again. Soon we will have La Palma or whatever other Canarian islands or the Azores, St. George, or Italy, or Germany, or France, or the Alps. Or wherever else on Earth where we have volcanoes. America, there are many volcanoes, North and Central and Southern America. Russia, Asia, Antarctica. Why not Svalbard and the Northern Pole? There's so much stuff going on underneath our feet, which isn't really understood in context with weather anomalies, or in this case, water anomalies. I want to show you something. That's also NOAA, National Weather Service, Climate Prediction Center. If you look at that, it's unstoppable. This is just this loop which we have to deal with. We are watching the North Pole. You can see the red and blue blobs there. Here on Earth, they indicate low or high pressure systems. You will notice there is this kind of geometry here appearing every now and then. That's due to the fact that we are watching the Birkeland Current from the northern side, which connects us to the sun. And it makes a loop through the sun and through Earth, so that's why we have a magnetic north and a magnetic south pole, because that's our connection to the sun. So there is energy going in and out. You could, in a way, maybe think about that. The blues are where it's coming in, and the reds where it's going out. So they are moving all the time according to the Birkeland currents, according to surface conductivity of Earth's crust, or where we have strong connections to the heavens. For example, the Kursk magnetic anomaly. There's a few pictures where you can see how they draw on it, like in terms of intensity. As more intense, at higher it goes up into the atmosphere. And for example, the Kursk magnetic anomaly. Let's take the picture of the surface conductivity anomaly. So that's the surface conductivity anomaly map I once found. And I think that's not a screenshot of a screenshot, that's the original screenshot. And you can click here, go to the website. Let's go to the website. I show you again. European Plate Observing System page not found. The requested page could not be found. It's gone. Contact us. Yes, I did. That's probably why we cannot find this picture anymore on their site. But I don't know, they didn't respond anything yet. I asked a few questions and showed my own observations and shared them with them, some things I've figured out and thoughts about them. So they took the picture down. So here we have the Kursk magnetic anomaly. And that's an extension to it, or maybe that's the whole surface or magnetic anomaly, I don't know. This is what I was asking them and stuff. That's the positive, the red, that's minus. So now let's have a look quickly at the Kursk magnetic anomaly. You can see that's google.com, not google.fi. Anyway, there are several pictures, and one particular I wanted to show you. BBC News. This is the picture I meant with they were drawing it in a way that how far up it reaches the intensity of the magnetic field of the Kursk magnetic anomaly. And since we know that the weather is entirely electrical in nature, we can emphasize that this might have, or this will have, a very big effect on local weather. These are pillars standing always there because ground is charged in a way. It is charged. It won't change until the big event happens and a possible huge amount of charge is flowing between those two areas, and it might change the polarity or whatsoever. It will be massive when it happens. And these kind of things are all over Earth. And they might change also, especially in places where it's not that much on the surface. Hence, if there are some big magma chambers underneath the surface and they can move. And as Earth is spinning faster, the mantle comes loose in a way, so there will probably more water movement happen below the surface and also magma movements and all these kind of things. And since the crust itself gets weakened too, the possibility that something will pour out of the ground in unexpected places or in places where we didn't have any happenings for many years. Yeah, you should expect this kind of events happening. Let me show you just an example. We are here on volcanoes and earthquakes application. Going over to Iceland. Vakrartsfjall. I want to point out just one single thing. 2021. New fissure eruption started. And now it started again. And before that, it has been silent for the past 10,000 years. Ain't that a coincidence? 12,000 year cycle of the sun. And now we have many, or at least a few very remarkable eruptions already witnessed in the last year or something. First Vakrartsfjall, then we had La Palma, biggest eruptions in 500 years. And then we had Tonga, biggest eruption ever. And now we have Vakrartsfjall again. And it seems to be so that the eruption is already 5 to 10 times bigger than the last one. And now they even say it could last for decades. So things are really ramping up. And just to round this up, we go again over to NASA. So now we have used NOAA and NASA. And the volcanoes and earthquake activity application. We are at solar activity. We want to scroll down. And then we have solar cycle. We want to click on this one. And hope that it would work, but it doesn't. It does. See this red line? This is already higher than this one. That's sun cycle 23, 24, 25. There were many people who were talking about the grand solar minimum, which happens every 400 years, like this kind of bigger sun cycle. That's just a very rudimentary simplification of the things we are looking at. Let's say that's 11 years. Between the sun cycles, they vary. It was for quite some time unclear, did the sun cycle 25 started or not? Did it? What have we had the Terminator event and such things? So these are 11s. Wait a second, I try to. 11 years. So this means we have to draw here a straight line up and following this line. You will notice very quickly that this red line here is very steep, and this is the predicted peak of the sunspot of the sun cycle 25, and there is still a distance to go. What do you think? How high this will rise up still until we reach the peak of the sun cycle? So, extreme weather. I will not dive into coral bleaching at Svalbard or alpine earthquakes, glacial earthquakes, mountain water, and geothermal activity, tornadoes expected in Finland, and such things. I just want you to show this. So if the sun is ramping up, is more active and such, the energy exchange between the sun and earth will be bigger. This is how we get those anomalies. I will leave it here. Thanks.